Alright guys, let me try to solve this. So, this question is asking how many remainders can result when the 100th power of an integer is divided by 125. So, the first way I'm going to go about this is list a bunch of them, see if there's a pattern. 3, 4, 5, 6, 7, 8. And of course, when brought to the 100th power, this is 1. 2 to the 100th power mod 125 is, well, 2 to the, 2 to the what, 128. 2 to the 6 is, so 2 to the 7. 2 to the 7, then that'd be to the 10th to the 14 times 2 to the 2. And then mod 125, this is 3 to the 14 times 4. And then 3 to the 3 equals 27. 3 to the 4 equals 81. 3 to the 5 equals 81 times 3, which is 3, and then 240, so 241. 243, oh my gosh. So this gives 243, so what is that? 243 minus 125? That would be 13, 3, 8, 1, 1, 118, 118 to the power of, that'd be to the power of 2 times 3 to the 4 times 4, which is times 81 times 4. 81 times 4 would be 4, 3, 2, 0. 324. 324 minus 250 gives us 124. 124 would be negative 1. So now we just need 118 squared, which is the same thing as take out 2 from 118, you get 2 and 109, or 59, sorry. 59. So right now we have negative 1 times 118 times 2 times 59. Because then if we bring these two together, we get 118 times 2. So then we get 16, 20, 200, so 236, minus 11125 gives us 1, 1, 1. So negative 1 times 1, 1, 8, times 1, 1, 1. No, sorry. Times 1, 1, 1 times 59. 1, 1, 1 times 59 gives us, this must be 11, which means this gets to be 11, brought down to 10, which means this is non-existent, 2, 5. Oh my god, I subtracted that. 9, 90, 900, 50, 500, 5,000. Well, 500 cancels out. You subtract 250. 200 times 250. This goes down to... This also cancels out. this goes down to 400, so 9, and then extra one here, because 4, 5, so down to 49. Negative 49 is our answer. 125 minus 49 gives us 15, 1, 11, 0, 6, 7, 76. So there's at least 2. Hmm. Hmm. Well, oh, okay. I know it's not 125 because 5 is divisible by 125. 5 to 100, but so is 25. So it can't be that. When divided by 25 is the same thing as when divided by 5 to the 3. So, if I'm thinking about this, I'd think that there's only 5 options for numbers. Oh yeah, because we know that every number with a 5 in every number that is divisible by 5 is divisible by 125 when it's like brought to the whatever power, the 100th power. Because then it'll be 5 to the 100 times whatever over 5 to the 3, which of course 5 to 3 and that'll cancel out, so that always makes sense. So we know that. I'm saying it's gonna be 5. I'm saying it's gonna be 5. I'm just trying to think in my head if that makes sense. Yeah, that makes sense to me. Okay, I'm gonna look at the answer now. Because my reasoning is that's gonna be a loop. For every 5 integers, it's gonna be 0. What is it, 14? Oh, it's 2. It would be 0 or 1. What did I do wrong? Okay. Where it says Euler's Toylent function of 125 is 10. Or totent. I don't know what that means. There may be quotient. There's so 2 cases which depend on whether a real number is relatively prime to 125. If n is relatively prime to 125, then n to the 100 equals 1, because of Euler's Toylent formula. If n is not relatively prime, it must have some factor of 5, and then, of course, that's divisible by 100. Euler's theorem states that a to the phi n is congruent to 1 mod n, where phi of n is Euler's Toylent function, which counts the number of positive integers x such that 1 is less than or equal to x is less than or equal to n, and GCD xn is equal to 1. Note that this only works for positive integer a, such that GCD a n equals 1. So only for relatively prime numbers. Hmm. I think I got it. Because every number that isn't 5 isn't relatively prime to 125, or is, so that's 100, because there's 25 multiples of 5. So maybe that's why. And then that just means every other number to the 100th power is 1. I don't know. But thank you guys for watching. I'll see you guys tomorrow. Bye.